Let's talk about cylinders and quadric surfaces. Let's start with cylinders. Assuming we have a curve, think of a curve, a green curve in R3, like this. Now, let's also assume that we have a line. So this curve lives on a plane, obviously, in R3. So, sorry. This curve lives in a plane. Now, let's assume we have a line that that passes through the curve. Call this curve C. Let's call the line L, like this. Maybe this line. You know what? Or this might be a little easier. I don't know. Make it like this line. I want this line like that. Okay. Now, if we can get a bunch of lines, think of all the lines that are on this curve that intersect with this curve, and then, but these lines also, oh, I think I deleted something. All right, so this is my line once again. Let's see, I want this line. This is my line, call it L. Now think of all the lines that are parallel to L, but intersect with C. So what kind of lines are these? So if we get, let's make them light green. So that, that, I don't know if this is working out well, but you get the idea. So we get all these lines. If we can think of all these lines and think of them forming a sheet, right? So they form like a sheet. Okay, like this. Okay. So this is what a cylinder is. The next example will be clearer, trust me. This is the worst drawing I've done, but it's okay. So this is a cylinder. Now you're wondering, why is this a cylinder? Well, for now, I'm going to tell you two things. Let me fix this, then I'll tell you two things. When you think of the word cylinder in Calc 3, forget about the cylinder that you know. So this is a cylinder you know from grade school, right? Okay. Once you hear the word cylinder, stop thinking of this cylinder. But at the same time, once you hear the word cylinder, know that this is also a cylinder in Calc 3. What do I mean? The word cylinder is a generalization of a bunch of things that follow this principle of having a curve C and then having a line that intersects with C and then gathering a bunch of lines that are parallel to L. All right? So you have your line L. So let me define this formally. So I can say given a curve C in a plane P and a line L not on P. All right. Now, a cylinder is the surface consisting of all lines parallel to L to L that passes through C. All lines parallel to that pass through C. Okay? All right. So we have a curve C. This is our curve C, the dark green curve. And we have a line that intersects with C. And then we get a bunch of all the lines that are parallel to L that intersect with C. If you gather all those lines and they form a sheet, that sheet is a cylinder. All right. One thing I want you to note about a cylinder is that it has an equation. A cylinder has an equation. And one way of knowing that an equation is that of a cylinder is that there is a variable missing. What do I mean? You have the variables x, y, and z, but either z is going to be missing, y is missing, or x is missing. All right? Now, that applies only to the kind of cylinders we're going to be studying in this course. The kind of cylinders we're going to be studying is cylinders that are parallel to one of the axes. That either, like this one is parallel to, the lines are parallel to the x-axis, or maybe the lines are parallel to the z-axis, or the lines are parallel to the y-axis. If the lines are parallel to the x-axis, then all the x-axis will be missing. If the lines are parallel to the y-axis, then if the lines are parallel to the x-axis, the variable x will be missing. If the lines are parallel to the y-axis, the variable y will be missing, and so forth. All right, I've said a whole lot. Let me do an example. So we have sketch the following cylinders in R3. All right, so this is y is equal to x squared. Isn't this interesting? If this were in R2, this would just be a parabola, all right? But notice the variable x is missing. No, z is missing. Z is missing. So the cylinder must be parallel to the z-axis. Axis. All right, so how do we sketch this? We focus on the x and y axis to begin with. We have the x-axis, y-axis, y, x, and then you have your z-axis. Okay? Now, try to draw a trace. Your trace should be a parabola on the xy axis. So if I draw a trace, a parabola in the xy axis, so what do I get? I get that. That's my trace. And then I make this run through or along the z-axis. So I just extend this to run through or along the z-axis, or to run along the z-axis. I mean to say, not through. All right? So if it runs along the z-axis, it's just going to increase. So we have that. Okay. So this is like a sheet, like a folded sheet. All right. Okay, so this is your z-axis. Z-axis. Okay. So this is your cylinder. So you can think of your curve as the curve C as maybe this curve. It could be any of the parabolas, and then the lines that are parallel to each other are these lines, these lines like that. Etc. Okay, so that's a cylinder. How about let's do another one. Number 2. Let's sketch the cylinder Y. Let's do Y is equal to, or how about this? Let's do Z minus cosine Y is equal to 0. So this must be parallel to the x-axis, since x is missing. So if you rewrite this, you just get Z is equal to cosine Y. All right, so we go to the Y Z plane, so we get that, and then that's Y, no, that's Z, and this is Y, and this is X. Okay, so what you do is you make a trace. So this is cosine, the cosine curve. This is your y-axis, that's your z-axis. Okay, now all you have to do now is run this cosine curve along parallel to the x-axis. All right, I hope I can do this. If I can't do it, then you get the idea. So like that. Yeah, so it's gonna go like this, I think. Oh, you know what? I'm gonna cheat a little bit. I'm gonna draw another one here, and then I'm gonna join them. You see? It still looks jagged, but you know what I mean. It's a little better. Okay. So, the iPad is not the best to draw. This would have been so easy for me on the board, but it's fine. We're not trying to be perfect here. So let's see if I do this. No, I'm gonna cheat. I know what I'm gonna try now. I'm gonna copy this, copy, and then I'm gonna paste it here. Let's see what happens. Does that work? Does it work? Does it not work? Okay. Okay. Maybe. So I'm gonna go like this, go like that. All right, this is my last try. I'm not changing it. Anyway, this looks like a corrugated sheet of metal. You know what I mean? So it just keeps going. It extends and just keeps going like that. Okay, it's infinite in length. All right. So this is the cylinder. Now let's try another one. How about x squared plus y squared is equal to 9? So this is parallel to the z-axis. to the z-axis. Oh, no. Yeah, it's parallel to the z-axis. So let's do it again. Z, X, Y. So let's get our trace. Our trace is a circle of radius 3. All right, because x squared plus y squared is equal to 9 is a circle of radius 3. So we have this, a circle of radius 3 on the xy plane. So this is y, this is x, and then you extend it all right, extend it on the z axis, so along the z axis. So this is actually a real cylinder. So okay, so another thing I want us to talk about is quadric surfaces. I'm just going to briefly introduce it, and we talk about it more in class. Quadric. So a quadric surface is any surface that has the equation of this form: ax squared plus by squared plus cz squared plus dxy plus exz plus fyz plus gx plus hy plus iz plus j equal to 0, where a, b, c, and so forth up to j are constants, and a, b, all the way to f cannot be all 0. Or cannot all be zeros. You know what I mean? Now, I'm going to write an example, and I want you to think about it. So I want you to describe, let's call this example 4. Describe and sketch each of these quadric surfaces. The first one is, let's see. The first one is x squared plus y squared over 9 plus z squared over 4 is equal to 1. The next one, actually this b part might be a little easier. Z is equal to 4x squared plus y squared. So in class, we're going to discuss how to sketch this and what they are, but I want you to think about them. All right? So I'm going to see you in the next lecture, maybe see you in class if you're taking the course.